On September 5, 1977, something extraordinary left Earth. Voyager 1, a robotic spacecraft no bigger than a small car, was launched into the cosmos by NASA. Its mission was bold: to explore the far reaches of our solar system, to visit worlds that had never been seen up close, and to deliver humanity's first real attempt to touch the stars. At the time, few imagined that this tiny machine would go on to become one of the most enduring and awe-inspiring achievements in the history of space exploration. Voyager 1 was initially designed to conduct close-up studies of Jupiter and Saturn, along with their largest moons and the surrounding magnetospheres. Alongside its sister spacecraft, Voyager 2, it would perform flybys, capturing stunning imagery and scientific data. What began as a planetary reconnaissance mission would eventually transform into a journey across the vast unknown, revealing that Voyager 1 was not just a tool. It was a storyteller, carrying back tales from the very edge of our solar system. In the early 1980s, Voyager 1 delivered some of the most breathtaking images ever seen. It showed us swirling storms in Jupiter's atmosphere, including the legendary Great Red Spot, a storm so massive that 3 Earths could fit inside it. It captured volcanic eruptions on Io, one of Jupiter's moons, proving that active volcanism exists beyond Earth. It gave us our first detailed look at Saturn's intricate rings and at Titan, Saturn's largest moon, cloaked in a thick, golden atmosphere. But what makes Voyager 1 truly exceptional is what happened after those encounters. Instead of shutting down after its planned 5-year mission, the spacecraft continued on, venturing into the uncharted regions of the outer solar system. As the decades passed, it drifted farther and farther away from Earth, still sending back data from a dwindling stream of instruments. By 2012, it had crossed an invisible frontier, the heliopause. This is the boundary where the solar wind from our Sun is stopped by the interstellar medium, the gas, dust, and magnetic fields that exist between stars. Crossing the heliopause was a milestone no spacecraft had ever achieved. It marked the first time a human-made object had exited the protective bubble of our Sun's influence and entered interstellar space. Out here, the environment is radically different. The temperature drops to near absolute zero. Cosmic rays from distant galaxies zip through space unfiltered. And the laws of physics, though the same in theory, may manifest in ways we've never imagined. Since that historic crossing, Voyager 1 has continued to feed us information, delicate signals sent from over 14 billion miles away. At this distance, light takes more than 22 hours to reach Earth, meaning every command sent to Voyager and every piece of data received is subject to almost a full day of delay. The faint whisper of its transmissions is picked up by NASA's Deep Space Network, an array of massive radio antennas around the world, each listening carefully for this aging traveler. What Voyager 1 has begun to detect in recent years has sparked a quiet revolution in astrophysics. According to physicist Michio Kaku, some of the data being transmitted challenges our most fundamental assumptions about interstellar space. The spacecraft has picked up oscillations in the plasma density, a type of sound wave rippling through the ionized gases of interstellar space, that are far more frequent and intense than expected. Instead of a quiet, static void, the space between stars seems to be alive with energy, changing on timescales that are difficult to explain. There are also patterns emerging in the magnetic fields Voyager is sensing. Some are chaotic, as expected, but others show unexpected regularity, subtle fluctuations that repeat over long intervals. This has led some scientists to speculate that Voyager the first of may be detecting the influence of large-scale structures in the interstellar medium. Perhaps remnants of long-dead supernovae or even hints of dark matter interactions. More controversial are the strange signal distortions that some have flagged. While most attribute them to instrument degradation or interference from cosmic rays, a minority of researchers wonder, could Voyager 1 be encountering signals or anomalies caused by non-natural phenomena? Though the idea is highly speculative, it's hard to ignore the allure of the possibility that something else might be out there, and that Voyager is brushing up against its domain. Operating in this realm is a technical miracle. The spacecraft relies on a radioisotope thermoelectric generator, RTG, essentially a small nuclear power source using decaying plutonium to generate electricity. As the plutonium slowly depletes, the available power drops by about 4 watts each year. To keep Voyager operational, NASA has gradually shut down instruments and heaters, carefully prioritizing which data streams are most valuable. In 2023, engineers even reconfigured Voyager's memory to bypass a faulty chip, an incredible feat considering the technology is older than many of today's scientists. And yet, Voyager persists. Beyond science, Voyager 1 carries a human message. Attached to its body is the Golden Record, a 12-inch gold-plated copper disc containing images and sounds from Earth. Greetings in 55 languages, the music of Beethoven and Blind Willie Johnson, and images of DNA, animals, and architecture. It's a time capsule intended for any intelligent life that might someday find it. The Golden Record isn't just a scientific artifact, it's a poetic declaration. We were here. We hoped. We reached out. The spacecraft also revealed something poignant. In 1990, at Carl Sagan's request, Voyager 1 turned its camera backward and captured an image of Earth from 3.7 billion miles away. The result was the now iconic, pale blue dot, photo, our planet appearing as a mere speck in a sunbeam. That image reminded humanity of its fragile place in the universe. In the vastness of space, everything we've ever known exists on a pixel barely visible. Today, Voyager 1 is traveling at roughly 38,000 miles per hour. It will continue its journey into the galaxy for millions, perhaps billions, of years, long after its instruments fall silent. Even when it stops communicating with Earth, Voyager will keep drifting, possibly passing near another star in 40,000 years. By then, humans may have changed beyond recognition, or vanished entirely. But Voyager will remain, a drifting relic of our earliest attempt to touch the stars. Each new piece of data Voyager 1 sends reminds us that space is not just emptiness. It is a canvas painted with mysteries. Some of these mysteries are scientific, about plasma density, magnetic turbulence, and cosmic radiation. Others touch the philosophical. What does it mean that the only object built by humans to leave the solar system is still trying to talk to us? What might it tell someone, or something, else if they find it? Could Voyager 1 have already passed through something extraordinary and simply not recognized it for what it was? Could the anomalies in its signals be a form of cosmic language we don't yet understand? As new projects like Breakthrough Starshot, LUVOIR, and HABEX prepare to take the next leap in space exploration, Voyager 1 remains a testament to the enduring power of curiosity. It serves as both scout and symbol, paving the way for deeper exploration, even as it drifts silently into the unknown. So, as we listen to the fading heartbeat of Voyager 1, one thing becomes clear. Its journey is not just about where it's going, it's about where we're heading to. Toward greater questions. Toward bigger dreams. And perhaps, toward answers waiting light years away. What do you think Voyager 1 will discover next? Could the strange signals be the key to a new understanding of the cosmos? Share your thoughts in the comments, and subscribe to Waves Discovery to continue exploring the greatest mysteries of space and time with us.